Okay, so last time we were testing adding things to our linked list, and your homework assignment was to basically do exactly what we did in class. That is, create an instance of a linked list, have the ability to display it. So initially it should display the empty list because a linked list with nothing in it is the empty list. And then add some crap to it and then show we display. And right now our add method always adds to the end of the list. Okay, so we now need to add some functions for adding to other places in the list. So for instance, adding to the front of the list. And just for clarity's sake, I'm going to rename add to add end. Okay? Which means that all of these guys out here need to be add end as well. Actually, will this fix it for me? Yeah. Aha! Convenience. All right, let's make sure that's all still working. All right, there's our linked list with all the stuff added to it. All right, so that's add end. Now, we're going to write another function here, another method, public void add front.
Shouldn't you change the thing recursively at the bottom so it goes back to it again? Is that what
This guy?
Yeah.
Yeah, definitely. Actually, why wasn't that an error in the first place? Oh, because we didn't, no, we don't need to change it recursively. Because a node still has the add method. Okay, so add front, this is going to, instead of tacking something onto the end of the list, we're going to tack something onto the front of the list. Well, how would we do that? So, let's look at our picture here of our linked list. So this is currently my linked list, and I'm going to create a new node. Let's say 7. And I want to add this guy to the front. What am I going to do? How do I insert this guy to the front of this list, so before the 5? What are the steps I need to take? Go ahead.
Have the head point to one and
Okay, stop.
yeah, and then have that point to what?
Okay, so order is important. Because if we just connect head to this guy, we just lost our pointer to this guy. Does that make sense? So order is important. So the first thing we need to do, if our list currently looks like this, we need to make this guy's next node point to the same thing head points to. So we need to do this. Then we can reconnect head to this guy. That make sense? So the order is important there, because if we connect head to our new node right off the bat, we just lost our pointer to this guy, and he's going to be garbage collected because nobody currently would point to him. Okay? So adding to the front says, well, we're going to create a new node. Node n is equal to new node, built using the payload that's passed in. Then we'll say n dot add head. So that will make n's next node point to whatever head points to. So if you look back at node, what does add do? Oh, actually we can't do that. We can't necessarily let's go back to your suggestion and call this guy add end as well. Our add method inside of node, his job right now is to set up the next node of this guy. Otherwise, he asks his next node to add something. That would actually work in this case. So can we just repurpose it? I suppose we can. So we'll say n.addHead. That's going to come in here. We happen to know that n is a brand new fresh node, correct? We just created him. So since he's a brand new node, we happen to know that his next node is null. Correct? So when we call n.add and pass it head, it's going to come into this method right here. We know we will never get to this else. So we know that this will just set n's next node equal to whatever we passed in, which is whatever head points to. So the very first thing we'll do, we'll create our node, then set n's next node equal to head. That's what that guy does right there. Then we'll set head equal to n. And that will add stuff to the front. What if we said add front and it was the empty list? Does this code still work? So we create a brand new node. We say n.add head. What's head equal to if it's the empty list? Null. Is that going to hurt anything, adding null as the next node? We're just overwriting the null that's already there, right? So no harm, no foul. And then make head point to this guy. So this will just function for empty list or not, correct? So let's test this. So we'll display the empty list and we'll say ll.add front, let's say 7. And we should have the list that's just 7. Oh, we didn't display it again. So we have the list that's just 7. If we add some more stuff to the front, let's add 5 to the front. The 5 will now come before the 7. So we should have the list 5, 7. Make sense? Okay, so that's add front. Add front was easier than add end. Why? What made add front easier than add end? The nature of linked lists. Oh, go ahead.
Is it because the head's already equal to null and you're just replacing that 0 with
Well, let's say no, but you're not as far off as it sounded like you are. Right now, we're implementing what's known as a singly linked list, where we keep track of the head of the list. Adding things to the front of the list is trivial because we always know where the beginning of the list is. We always have a head. Head's not necessarily always null. Head points to whatever the first node is, or null if it's the empty list. But the point is we always know instantly where the front of the list is. So adding something to the front of the list is trivial. Adding something to the end of the list, not so trivial. Why? Because we have to traverse all the links to get us to the end of the list. How do we know we're at the end of the list? When we finally get to a node whose next node is null, right? So we're walking the whole length of the list. So imagine, so this goes back to our conversation about arrays versus linked lists. Arrays are fast, but memory hogs. Linked lists are slow, but memory efficient. And there's your best evidence of slow, is that in order to add something to the end of a linked list, we literally have to walk the entire list linearly. Start at the beginning and make every single hop, follow every single path to the next node, to the next node, to the next node, until we finally get to the end, and then we can add something. Make sense? Not a big deal for relatively small data sets, but what if you have 1 billion records? That's going to take time. Adding something, just adding one thing to your data, when you have to walk through 1 billion things to get to the end of the list, could become problematic. Does it hurt to keep track of the tail of our list? what would it take for us to keep track of the tail of the list right now? How would we modify our code? Let's go into our linked list. We're going to add another pointer, private node tail. When we first create a linked list, tail will also be equal to null. That's the empty list, right? A list that has nothing in it, head and tail both point to nothing. When we add something to the front, how do we set tail? When do we set tail when we add something to the front? There's one condition
What is the first thing?
when we're adding something to the front of the empty list. Because at that point, if it's the empty list, tail is currently null. And we need to set it to something. After we create our node n, we'll ask the question, if head is equal to null, if that's currently a true statement, we will make tail point to n. That make sense? Because we know this guy, not only will he become the new front of the list, he's also going to be the new end of the list. But only if we're adding him to the end of the list. Otherwise, if there's already things in the list, adding him to the front will not affect the tail of the list. Correct? All right, so this if statement takes care of the special case when we're adding something to the front of the empty list. But note I'm asking that question before we start adding things onto the list. Because right here, head is no longer null. So I need to ask it first, or at least ask it before this line. All right, so if head is null, this is the first thing we're adding to the list, go ahead and make tail point to this guy because he's going to be the new end of the list, then do the same crap we did before. But what if we're adding to the end? This becomes kind of an interesting question. If we're adding to the end of the list, if head is equal to null, that means head points to n, and so does tail. That's the trivial case, right? The one list, the head and tail are both the same. But if we're not at the end of the list already, and we need to traverse our list, that is, talk to this guy and have him pass through all of the elements that are in the, I'll have him traverse the entire list till he gets to the end, and then pass it. How do we set tail? Go ahead.
You could have add return a value.
We could have add return a value. Now what I'm going to do, just for clarity's sake, I've changed my mind about a decision I made earlier in class. I'm going to create a method called setNextNode. And this guy, he's just going to be a setter for the next node variable of a node. Okay? And the reason I'm going to do it for a couple different reasons. We're about to simplify our linked list a little bit. Still going to do the same crap, but tail makes things easier. So back in linked list, instead of calling n.add up here, I'm going to say n.set next node to head. Functionally, this line does the exact same thing as the line before that did. But I think this paints that picture that we drew here a little better. That is, here's n. Set my new node's next node to the same thing that head points to. That make sense? Functionally, it's identical. Now, head and tail right here. If we are not looking at the empty list, that means we're looking at a list that has at least one thing in it. Where's the end of the list? We have to unravel the recursion inside your minds. If I'm in this else right here, where is the end of the list? Let me ask it a different way. If I'm in this else, is tail guaranteed to already be pointing to the end of the list? It is. I don't need to go through all this crap of traversing the list to get to the end. I know where the end is. If this is my current list, what was I doing with that guy? It was a who?
Pointer counter.
Oh, that's right. Thank you. Question, besides Abe, what do we use pointer counters for? Interesting review. Go ahead.
To see whether or not the garbage collector needs to
Yeah.
take it.
For automatic garbage collection. Once the counter drops a 0, that means nothing currently points to this guy. Therefore, pick them up, clean them up. All right. So in this case right here, head points to the front of the list, tail points to the end of the list, right? So how do we add a new node? Let's say we want to add a 3. How do we add him to the end of the list? What's the steps to add him to the end of the list? Don't all speak at once. This is just like fun with pictures. So this is what my current list looks like. I need to include this guy at the end of it. How do I hook him up? What do I need to do first? Go ahead. Set this guy to this guy. Okay. So set tails next node equal to my new node. Then do what?
Set tail, right?
Yep. Then make tail point to the new guy. Just like that. So add end. Let's get rid of this first. And then let's go inside here and let's dump this. We don't need that add method inside of nodes anymore. Go back to linked list. And what will we do? We create our new node. We're going to set n.set next node equal to, actually, I'm sorry, tail.set next node equal to n. Then tail is equal to n. So we did this. This was tail. This guy was pointing to null out here. We created our brand new node n right here. Then we set tails next node equal to n. That's what the first line of code here does. Tails next node is now n. Then we make tail point to n. That make sense? So now what's interesting is here's a node. All the complexity in node right now is in displaying it, right? The hardest part of node right now is to display itself. And here's linked list. add front, and add end. What's it complaining about here? There we go. Add front, add end. Aren't these methods basically trivial? This is your whole homework assignment. And you solved it this sort of kind of recursive way. But isn't add end a whole lot easier now? No recursive calls. Go to the end of the list. Where is that? That's wherever tail points to. Hook up the node. If I'm adding to the front, go to the beginning of the list. Hook up head. Yeah, and under very special circumstances, set up tail as well. Make sense? So now, back in driver, we can add front, add end. So let's add some stuff to the end. Let's do a 13 at the end. We'll do a 27 at the end. And we'll say add front 2. So in the end, our list should be 2, 5, 7, 13, 27. Because of the order we added everything. 2, 5, 7, 13, 27. That make sense? So now we can add to the front and back of our list, and we actually simplified adding to the end of the list by incorporating in keeping track of the end of our list. Okay, no harm, no foul. And we just added a whole bunch of performance benefits to our linked list now. Even if we have a billion records, adding something to the end now takes no time at all, because we can immediately go to the end of the list because we're keeping track of it. Okay, now for the tough method. What do you think's coming next? We add to the front, we add to the end. Add somewhere in between, right? Public void add at index. Int payload, int index. And we'll treat linked list just like we treat arrays, where it's a 0-based index. So that means that if index is equal to 0, what will we do? Yep, add front, the payload. So we could just utilize our add front method if they say add something at bucket 0. What about add end? How do we know the index of the end of this linked list? We have another performance issue here. We can easily go to the end of the list, right? But we don't necessarily know what bucket that is, because we're not keeping track of the number of elements in our list. Wouldn't it be helpful if we could ask our linked list its length, just like we do for arrays? All right. Public int length. So how do we do that? How do we keep track of the length of the list? Just like the length of a string or the length of an array, length is the number of elements that are in there. Well, length of a string is the number of characters in the string. Length of the array is the number of buckets the array was built to hold, not necessarily the number of elements that are in there. So how are we going to know the length of our linked list? Go ahead.
Anytime you add your element, you add to a variable, add one to a variable.
Okay. So we're going to create a variable, private int number of elements. And in our constructor, we'll set this dot number of elements equal to 0, because the empty list has 0 elements in it, right? Every single time we add something, so whether we're adding to the front, we're going to say this dot number of elements plus plus. or we're adding to the end this dot number of elements plus plus. Regardless of which of those we're doing, every time we add something, number of elements goes up. So what does length do? It returns this dot number of elements. So if I come out to driver, and after I display my empty list, I say system.out.println length colon concatenated with ll.length. I should get a 0. If I do the exact same thing here at the end, I should get a 5, right? There's our 0, there's our 5. So now again, adding a very small amount of complexity. Very small amount of complexity. We're able to keep track of the number of elements we've added to our list by just adjusting an integer. Now, what's the last legal bucket? Sorry, my eye is doing something crazy. Relax. Okay. Where is the last legal bucket in our linked list right now? Length minus 1, just like strings. So inside our add at index, we can say else if index is equal to this dot length minus 1, then we can say this dot add end payload. Now I'm going to introduce you to exceptions. We've dealt with exceptions a little bit in here, right? As well as 250 with our try catches. Remember those guys? We've done some try catches with some the IO crap we did. Yay, nay, maybe? I think we did. Okay. So, anyways, exceptions are built into the Java language. Here, we'll create a slide out of this. Hopefully before I pass out due to eye pain. Must have just got something in my eye. I don't know. It's like throbbing. Does my left eye look messed up or anything? Well, if it starts squirting blood or anything, you let me know. We'll probably get pink eye like Costas. Have you been watching that in the Olympics? He started off, he had pink eye in one of his eyes, and it looked all messed up, and then it spread to the other eye. So he had to, like, I don't even know if he's doing it today. He didn't do it yesterday. He had somebody else fill in for him. I mean, you couldn't even, like, make eye contact with him. It was bothersome. It looked so bad. So, I mean, and I don't know if it's painful or he's just basically blind. His eyes are all watery and stuff. He's just walking through life as a blur. So, exceptions in Java. Think of exceptions as kind of like objects. So in Java, if I go to the documentation, java.lang has in it, I believe it's in java.lang. Yep, we have something just called an exception. Okay, so an exception is an object. It's also something called a throwable, which is an interface. We'll deal with interfaces at some point in here. But it's a throwable, which allows us to do that try catch, or also allows us to pass the buck by throwing the exception. And then we have this thing called exception. So an exception is a generic exception. And the purpose of exceptions in Java is to allow us to gracefully react to errors. So good examples for like file I/O. A file not found exception means you tried to open a file that didn't exist. Well, rather than your program just crashing, it allows you to try to open a file, potentially catch the file not found exception, and do something as a response. Maybe you create the file, then open it. So now you just kept your program from crashing, and now your program, the very first time it goes to launch, if the file it doesn't exist, it creates the file, and then everything's happy, right? So that's the purpose of an exception. But there's a generic exception. So the lazy person's way of doing it is every single time that something potentially could throw an exception, you can just say, try to do this crap, and if anything bad happens, catch an exception. Because all of these other exceptions, here, I'll just pick one, illegal access exception, whatever that is from. You see that this guy is actually an exception. So illegal access exception is a reflective operation exception, which is an exception. So if I say catch exception, that will catch everything that is an exception. So it's a catch-all. Otherwise, a try can have multiple catch statements associated with it. So I could do something, let's just do it in the code here. So I can say try to do this crap, and I could catch IO exception, E, do IO exception reaction crap. I can then choose to catch a file not found exception and do file not found exception crap. So on and so forth. You can have 2,000 catches if you'd like. So anything that happens inside this code, if an exception gets thrown, the correct catch will happen for us to capture it. Okay? Well, when we write our own programs, we might choose to have exceptions occur. Right? Well, we can build our own exception class if we'd like. How would we build our own exception class? If I wanted to create a linked list exception, how would I do that? I'm going to ask you again in about 5 minutes. I'm going to show you how to do the easy exception, and then we're going to do a custom exception. So back in the documentation, I'm going to click on java.lang exception thing here. And we see when we create an exception, one of the constructors is we can pass in a message. All right. So what I can do here is in my code, I can say that add at index, this guy throws an exception. So I'm going to advertise that something bad could happen inside this guy. If index is 0, add to the front. If index is the last index, add to the end. Else if index is less than 0 or index is greater than this dot length minus 1, what are we going to do? We are going to throw a new exception passing the message linked list error index colon, let's concatenate on whatever the index was, is out of bounds. Put a couple exclamation points at the end. So we're going to tell them that whatever number they pass us, and we're going to give them the number, so they might say, add something at bucket -7. No. Add something at bucket 4068. No. And it's going to give us these errors. That make sense? Now, so that's all we're going to do in added index for right this second. We haven't actually handled the case where we're really adding something at a specific index somewhere in the middle. So we haven't done the hard part yet. But let's go ahead and test how these exceptions work. So I'll go into driver. And just for right now, I'm going to say that main also throws an exception. That way I don't have to do this inside of a try catch, although I will soon. So I'll get rid of all my displays for a second. Well, I'll keep our last display in there just for right now. So if I run this right now, we see that we get our list with all the stuff in it. Now, I'm going to say ll.add at index. We're going to add a 14 at index -8. This shouldn't go well. Okay? -8 is out of bounds. So it's going to call added index. It's going to say, oh, well, -8 is not equal to 0. So don't do this. -8 is not equal to the length of this list. So don't do this. Is -8 less than 0? It is. So we're going to throw an exception. We're going to yell at them and say linked list error, blah, blah, blah. Do this crap. That's going to boil down here. This guy's going to throw that exception. And main here passes the buck up to the virtual machine. So we should just see our error message pop out here. So there's our main java.lang exception. Linked list error. Index -8 is out of bounds. So we just create our own little error message. Make sense? Now, if we choose not to throw the exception in here, now our code has a bug in it. See this guy's highlighted? Hover over it, says unhandled exception, type exception. So I'm going to go ahead and we're going to surround with a try catch as our second option. So we're going to try to do this, and then we're going to catch our exception. We'll still print out the exception thing at the end, but we'll go ahead and do a system.err.println. Oops. To show that we can intervene as part of the exception. Now, what's cool about that notice that I'm still alive. Still happens. Our program did not crash. Does that make sense? So by trying to do this and then catching it and doing something as a response. What did I do as a response? Well, I just said oops. And then I printed out what the exception is. So I really did nothing except advertise that, by the way, I caught this. Oops, here you go. And then I just continued on with life as if we had added the guy. Okay? So I get to gracefully handle errors and keep my program going. As opposed to this guy, where we say throws exception. Notice that still alive does not happen. Our program indeed crashed because we left it up to the Java virtual machine to generically handle the exception, which means here's the error I got. Thanks. Program over. Make sense? All right. So now, I don't want to have this throws exception thing. We want to have something called an Amish exception. Pretty sure that's not built into the language. I would have used linked list exception, but it's possible that's built into the language. I'm not certain. But I'm very confident that the Amish exception is not built into the language. So we're going to need to make our own Amish exception.
We made it already.
That is true. Okay. So I go back to my question from a few minutes ago. How do we pull that off? Everything that you need to know to answer this question, we've looked at in this course, in last course, and today. How do we make our own version of an exception? I'll give you a hint. Want a hint? Or does somebody think they know? And it's just not saying anything. We have poor voter turnout. Or poor participation. You want the hint? Inheritance. It was a very good hint. See if you can run with that. I guess I'll relax for a bit. You guys mull it over. Are you guys playing a game or are you actually Googling how to make your own exception?
He's in a flip.
Huh?
He's in a flip.
How are we going to do this?
You tell me. You do it.
Okay, children. You tell him you did it.
No, I didn't do it. The ghost did it.
So what's the deal?
You make a class.
Okay.
Amish exception.
Do what?
You make a class called Amish exception.
Okay, so I'm going to do that. So far, so good.
There's more. You changed super class. Oh, fuck.
Well, we can do it there. But let's do it out here. Okay. I have my Amish exception. What do you want me to do now?
Extends.
That's exception. So I created my own class called Amish Exception, and I said, this guy is an exception. So he gets everything that exceptions have. Do I have to do anything else in here? As far as we know, no. He's just called an Amish exception. He's actually nothing more than a normal exception, but just kind of a new name, a synonym for exception. So now what I can do out here is I can say in linked list, this guy throws a new Amish exception. Oh, we do need to do one more thing. I'll show you the error message, and then you tell me how to fix it. It's another interesting error message is the constructor Amish exception that takes a string as a parameter is not found. So what do I need to do? So what do? Well, for starters,
Define it.
Yeah, let's not turn this into rocket science. It says there is no constructor for Amish exception that takes a string. Right? So let's make one. So we're going to go into our Amish exception class. And we're going to say public Amish exception string S, just like that. So I made one that takes a string. Is this dude happy now? He is. So is everything good? So what do I do?
Yeah, just type in Amish exception where you say throw exception.
Okay. Well, for starters, though, I'm throwing a new Amish exception, and we're going to say that this guy throws an Amish exception. Actually, did we need to type in throws Amish exception? Or could we have left it Amish exception? The answer is I can leave it Amish exception. Why is that?
You're creating a new instance of it.
Okay, what does that mean?
You're calling it within, so you don't have to call it twice.
Is an Amish exception an exception? All Amish exceptions are exceptions. Why? Because Amish exception extends exception. Not all exceptions are Amish exceptions, but all Amish exceptions are exceptions. Make sense? So I'm going to throw a new Amish exception. I can say throws exception here. I can say throws Amish exception. Doesn't matter. So I'm just proving the point that you didn't need to say Amish exception up here, but we'll say it. We're going to throw an Amish exception. That's going to come out to driver. And driver is then going to throw the Amish exception. So is this all we need to do? Let's go ahead and run it. We have an Amish exception. Where's our message? We wrote this beautiful error message here. Linked list error, blah, blah, index, blah, blah. Right? Yet it didn't show up.
We didn't tell the Amish exception to print out the message.
Well, exceptions already know how to print stuff out. It printed something out, didn't it? We didn't tell it to print this out, did we? Still did it. Let's go into the documentation. Everything you need to answer it is on the screen right now, from this point down to the bottom of the screen. So how do I fix this? Want a hint? Super. The hint is super. That's a really good hint. I'll give you another hint. It's the same hint I gave you before. Inheritance. Super and inheritance. It's the double whammy hint. It's a really good hint. If you got something for me? You got theories?
Yeah, it does. No, I don't.
Why are you so nervous?
Dave's giving me weird messages.
Are you afraid that I'll make fun of you if you get it
You're
wrong?
gonna make fun of me anyway.
Right. Exactly. Exactly. Here's our Amish exception. This guy is an exception, correct? I wrote my own method that takes in a string, but I'm doing nothing with it, right? Why did I write this method that takes in a string? Well, the error message seemed to indicate that I should, correct? So I did, and it stopped complaining. So fine, now it's working-ish, Amish-ish. It's working Amish-ish. But it's not actually giving me my message. Why is that? Well, I'm not doing anything with this message. Back to the documentation. Everything you need is from here down. The hint is super and inheritance. What do I need to do with that message?
Can you use those constructors?
You could. Is there one of these constructors in particular that you think might be helpful?
So that takes a string message.
This guy, okay. And how do we use that exception? Or how do we use that constructor?
Somehow using super, but I can't remember.
Somehow using, okay. So we need to somehow call exceptions constructor inside of Amish exceptions constructor. How? Did this last semester. Another hint from your notes last semester, it must be the very first line of this constructor. You cannot have anything before it. It's a special object-oriented thing. Who is Amish exception's parent? Exception. When we are inside of Amish exception, the way we refer to my parent is the keyword super. So my parent has methods. I can say super dot and call upon his methods. But I can also utilize my parent's constructors by saying super, in this case S. Why? My parent has a constructor that takes in a single string. And we know that's the constructor that has the magic we need. We don't know how this guy's implemented, but we just know he does what we need it to do. So I can reference my parent's constructors by saying super and then passing it the appropriate parameters. So this will call upon my parent's constructor, the one that takes a string. It'll just pass on the string that we took and do all the magic for us. That make sense? And then when I hit play, we see we get our message. Does that make sense? Okay, so the interesting thing there, it actually goes back to an interesting rule of constructors. Why is it that I'm able to just say super and it knows how to call my parent's constructor? Everything you need to answer that question is on this page right here. Why is it that I can just say super and it knows to call my parents constructor? Yeah, I gotta get working on these coffees.
In that constructor there.
I don't think so, but tell me more. Or is that it? that's it. That's what I got. Okay, no.
Is it because it's within an exception constructor that takes in a string? So it's kind of assuming that
Well, let me try asking you a different way. If I were building a brand new exception, one of these guys, I would say something like exception E equals new exception, blah, 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 whatever string I wanted to pass it, correct? Why is it that I'm able to just say super here instead of exception? How come when I just say super and follow it by parentheses, that's the syntax that says this is the constructor I'm talking about, why does it know internally, if you were the guy writing Java, how does it know how to call that parent's constructor?
The Amish don't play by no rules.
They don't play by no rules. Another hint, I'm going to highlight 2 lines. And the 2 lines, I'm going to highlight 2 sections of 2 lines. And the answer lies in those 2 highlights. All right, you ready? It's like a game show. There's section 1. Everybody got that? It's in there. There's section 2. Section 1. Section 2.
Because it inherits them.
Inherits what?
Well, it would inherit everything of its parent.
That's a true
Amish
statement.
Exception would. Yeah.
That's a true statement. Since Amish exception extends exception, he inherits everything that exception has. So I agree, Amish exception certainly has access to his parent's constructor. But why is it that Java is able to take this line and know that we're talking about a constructor? Or, maybe more to the point, why is it that Java is able to take this line and know how to call the constructor?
Because of the parameters.
That's how it knows how to call which constructor. That's true. Because I've shown you 2 constructors over here. One takes no parameters, one takes a string. There's a couple other ones. But, in any case, I've shown you 2. So it can detect which constructor to call based on the parameters you sent it. Java, like some other object-oriented languages, but not like all object-oriented languages, requires that constructors have the identical name to the class name. So if I say that Amish exception extends exception, I'm saying that this guy extends this class named exception. Java knows that the way you call the constructors is by the same name as the class. Does that make sense? So this is evidence as why Java requires the class name and the constructor names to match. All right, so we can call upon our parent's constructor there. So all we're doing is passing the buck. We're saying, okay, I'm going to have a constructor that takes in a string. And what does this guy do? He just calls upon my parent's constructor and passes it that string. And then I wipe my hands clean of it. Nothing, right? All right, and then it just magically works. Okay, make sense? All right, so there's our Amish exception. And the whole reason we built that is just so we can deal with the error message that occurs when we have, actually, let me show you something interesting here. So I'm going to go back out to driver. And rather than throws Amish exception, we're going to surround this guy with a try catch. So we're going to try to do this stuff. we will catch exception E and do a system dot, we can do system dot out or system dot ERR. ERR is a, this is actually an interesting thing to show you. We'll say blah in there. So we'll see that we have our exception, then we still get still alive. Notice that it shows up in red when you use system.err. That's just something that Eclipse is doing, as opposed to system.out. Notice also that they showed up out of order because of the way error stream is handled, and I'll show you that here in a second. We're going to run this outside of this. Okay? But now what happens if I say catch Amish exception E, system.out.println woot. Says this guy's an unreachable catch block. Why is that? Why is he unreachable?
Exception already catch it. Yeah.
Exceptions are catch-all, right? What if I just move this guy above him? Now it's cool, right? This is a more specific exception. So we're going to try to catch this guy. And in a worst case, this is almost like your global else. Catch whatever exception we got. That makes sense? So now when we run this, we're not actually going to print out the exception because I never actually print out E's exception. I just print out woot. So this is just going to display woot. Makes sense how that works? Now, interesting thing here. Let me do this for int I. Well, actually, here I'm having to mess with this program. I'm going to do it in a separate program out of my terminal. Okay, so here's my program. I have two for loops that are just going to run through 10 times. The first one's going to print out I through system.out. The second one's going to print out I through system.err, which is the error stream. System.out is standard output. System.err is standard error. System.in is the standard input, which is the keyboard. So I'll go ahead and save this. We'll compile it. And I'll run it. Doesn't look like anything special there, right? Print out 0 through 9, then print out 0 through 9 again. I'm going to run this again. And I'm going to redirect the output to something called output.text. Here's the contents of output.text. It didn't do it twice, just once. I redirected standard output to that guy. as opposed to if I want to redirect standard error, I say redirect the second stream. And here, just so we can tell them apart, give me a second here. Let me start this guy off at 200 or 2000 to 2010. Okay, so if I do java.test and redirect standard output, we see we still get the 2000. We still see standard error, right? But more output.text, we see we get 0 through 9. If instead I redirect standard error, we see we get standard output out to the screen here instead. And standard error is inside here. We can also output, I think this will work, both. It doesn't like that. I think maybe it's this. No. I think I can redirect both at one time. That guy right there says append to the file that's already there. So if I say 1 this and then 2 this, will that do it? It doesn't like. I don't remember the Unix command to redirect both. There is a way to do it. But in any case, that's a kind of an example of why one might use standard error versus standard output. It's for logging errors from a program. A lot of programs have log files, and you're maybe not interested in the standard output test stuff, but you're interested in anything that's an error, right? So anything that's an error, it would be appropriate to print out to system that error. Not something you're going to run into very often, not something you really even need to worry about when you're writing your own software, but punchline is that that's what it's for. Okay, so you see there's 2 separate streams. Okay, so now back to our linked list. Currently, we have added index, and this guy says if the index is 0, we'll add to the front. If the index is our last legal index, we'll add to the end. Otherwise, we need to add at a specific position. That make sense? So, else add at pause index. For homework, and I will give you linked list and node as a starting point. In fact, I'll just zip up this code so you'll have a working starting point. Okay? So for your homework, homework number 3. Finish implementing add at index in the linked list implementation attached below. And this is going to be due on Tuesday. Okay, and I'll go ahead and I'll attach that code right now. So questions, comments, concerns, bribes. I would encourage you when you're doing this assignment to draw pictures. Kind of like what we've been doing inside of Keynote here. That will become very helpful as you do this assignment. Okay, so if I say I want to insert something at position 1, let's say this is an 8. That means that the new linked list should look like this. He should become the new bucket 1. That make sense? Okay. I will see everybody on Tuesday. Have a good weekend.